Hello, both of y'all. Oh my goodness, it is Saturday. It is 3 in the afternoon for me, and welcome everybody that's here. Today is going to be a little bit of an unusual video for me because, or a live. We're going to let me mute the phone now that I'm looking at it. We're going to see. That's why I needed to mute it. Go away, mute. There we go. Uh, I've been playing with inlays and trying to figure out the workings of Millmage, and I've discussed a little bit with Chris, and I still don't have a complete grasp of the terminologies that Millmage is using. I'm struggling with figuring that out. And a large part of that is because I don't understand the terminology that the industry uses. So it's a big learning curve because I've got to, when I watch Garrett on IDC Woodcraft, and he talks about his different functions that he uses and different practices that he uses with Vetric, well, they don't transfer to Millmage because they're not called the same thing. And so I'm like, okay, so I see what you're doing, and I understand what you're doing, kind of, but now I got to go figure out how to implement those techniques into Millmage, and they're called something completely and totally different. And I didn't fully understand what he was doing to begin with, so now I'm struggling. So I had to go back to the absolute basics. Not knowing anything about, or actually just foregoing any of that terminology. I understand when you're doing an inlay, this much I have wrapped my head around. You want to leave a glue gap. You don't want to have your male inlay as tall as the pocket of your female female inlay pocket, because you don't want them to be the same height and same depth, so when you squeeze them together it pushes all the glue out. So you leave a little glue gap at the bottom. Got that done. But that creates a problem. It creates a problem. It's okay, well, that's simple. All you need to do is just simply, you if you've got a 3 millimeter pocket, then you create the male inlay at 2.8 millimeters high. So that leaves 0.2 of a millimeter glue pocket. Easy, simple, done. It's not that simple. And I'm going to show you a couple of visual representations of the headaches that you run into. And Millmage has a lot of this math built into it, but I'm still trying to figure out how their math works. Why do, and we're going to go into these different things in their operations. And Millmage has done some really cool things where when you create operations in Millmage, it has some it has some suggested operations already that then all you have to go in and fill in is, okay, well, this is the bit that I'm using and these are the parameters for my cuts. And then it has, and Chris showed me that some of these operations have default settings, and I'm having a hard time seeing. They have default settings so that when it's optimal to move the bit, your tip to where you're cutting inside the line versus cutting outside the line, some of these pre-programmed operations do those functions for you. So it's intuitive as long as you understand what you're looking at when you look at what you're looking at, okay? And I see a bunch of comments. Once I can see, I'm gonna look and see what we got going on here. But really what I'm gonna talk about today is for those who, oh wow, hey, there you are. For those who have never done an inlay, and this is an inlay I did with using the laser. And it's a lot different doing inlays with the laser versus doing inlays with the mechanical bit. Because the laser, well, I should say, let me rephrase that. The V bit. If you were to do inlays with just a regular end mill without a V carve, then you would probably pretty much have the same techniques, pretty much. But V carve is what we're talking about. V carve inlays. They are where it gets complicated. It adds a whole nother layer, lots of layers actually. But there's a female pocket of a star, and there's the male. Now this is done in that cedar that I've been practicing with, and this just chips away and falls away. So these are just good pieces to test with. But I did these two using the settings in Millmage, and it works, but it doesn't work as well as, and a lot of it has to do with the two problems. Oh, now Patrick's calling. You know what? I'm gonna take this. Hey Patrick, we're live right now. How you doing?
Oh, not bad.
So I do want to speak with you, but right now is not a good time. Say hello, Patrick.
Hello. Sorry, I was home from work, so I thought you'd get calls. I forgot to yesterday.
That's all good. I'm live right now. And today is right now. This is Hobo with Wood Chips at 3, and then at 9 tonight I'll be doing the laser show for everybody who doesn't know. And you guys are not doing lasers tonight, right?
No.
Okay, that's all right. So if you get time, shout at me tonight, or maybe you might want to come in and say hello to everybody in the lasers tonight.
Yeah, I can do that.
All right. What time would be a good time to call you back?
I'll be home all evening.
All right. I'll talk to you in a bit. And everybody in the stream saying, "Hey, Patrick. Hey."
Oh, hello. Have a good afternoon, everyone.
All right. I'll talk to you in a bit. All right. I've been trying to get a hold of Patrick to try and make sure we get our schedules coordinated so we're not conflicting with each other, because I really don't want to be in a situation where we're doing any heads up. That's not good for me. It's not good for you. And it's not good for them, for the laser people. So put that back. All right. So let's see here. Go back. All right. Good. All right. So no comments I got to look at. All right. So the V carve is where it gets a little bit confusing. And as I begin to figure out the presets that Millmage is using, I may fully embrace those, and I will continue to work at them. I've got high expectations of myself. And, there was one of the videos I watched from Garrett when he did the inlay with his feather, where he was showing how to do the V-carve inlay using Vectric. He was explaining about needing to use or to leave the glue gap, and you also need some side clearance and all this and he's at one point he says, there's lots of different people who have lots of different ways of calculating this or calculating that, and sometimes it gets overcomplicated. And just use these values because they work. Here are the values. Plug these in here and here, and they work every time, period. Well, that's good if you're using Vectric. I'm not. And I don't know that I will be, because I don't know that they'll ever be able to afford it. But I want to understand what using those values do? Why am I using them, and what's happening when I use those? So let's jump over to Millmage, and what I'm going to do is I'm going to show you I'm going to draw just a 10 millimeter circle. Okay. I've got a 10 millimeter circle on there, and that's going to be a solid pocket. It's not going to be like here. I did the star where it's got I didn't completely cut the inside of it out. We'll just cut the whole thing out. So it's just a 10 millimeter dot that needs to be filled with an inlay. And we're going to do it using a 30-degree V-bit. So let's jump over to Millmage. And here is my 10 millimeter dot. And I'm going to do that in with a V-carve 30-degree bit. And when I do, if it's 10 millimeters, if I look at a cross section, I don't want that. I want my rectangle. If I look at a cross section of that carve, if I have it at 3 millimeters deep, and it's going to be 10 millimeters in diameter, there's what is beginning to be the pocket, but here's where it starts to get a little bit complicated. We're doing it with a V-bit, a 30-degree V-bit, which simply means the bit shaped like a V. In fact, with Millmage, when you're inputting and creating your tool library, it will create a visual representation of the tool. So if we go over here and let's just go ahead and select this, and I'm going to put it on an operation, and I'm going to put it on a pocket. I'm not going to use the any settings, right, or any inlay pockets or anything right now. I'm just going to set this up so I can show you this tool. Here we go. So when I go to my tool library, it shows me based on the parameters that I set up when I put in my tool, here's what the tip of my V-bit looks like. It comes down to a 0 point. It comes to an actual point, no flat end. Some of your V-bits will have a flat end on them, but this is a 0 point V-bit with a 30-degree angle up each side to the extent of that flute length, which was right at 0.6 millimeters, if that's right. So anyway, it's a 30-degree angle on the side of that bit, which means this profile is not going to look like that. But if I'm cutting on the line, and this is right now, we're not talking about any of the presets that Millmage has built in for their inlays. If we're just simply cutting the line of a 10 millimeter circle using a 30-degree V-bit, the point is going to be right here. But that because of the shape of that bit, if this bit is rotated at negative 30 degrees, I fat fingered something, negative 30, there we go. If that's 30 degrees, that pops in right there. There's where that point's at. This one rotates 30 degrees. And that point's right there. Well, this then begins to look like, let's see here, we got to go break, 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 and break. And now delete that, go back up here, extend these out. So now this is what my pocket looks like. I'm engraving on the screen. It's just a simple circle. It's a 10 millimeter circle, but that V-bit following the line is going to have that. What if half of the width of that, if I'm doing it with a 1/8 of an inch bit, half of that, I'm forming a triangle. The center of that bit is straight up and down, comes to the very point of the bottom of that, but then 30 degrees out is how that shape of that bit comes up. So from there to there, I've got a triangle. And that's what forms that extra removal of that material around that perimeter. So I have now, if I look at my ruler, this down here is 10 millimeters. That's how wide that bit, that circle was, is 10 millimeters. But at the surface, it's 13.46 millimeters. It's almost 3.5 millimeters additional, which is about right, because that should be about what the width of the bit is, if I'm thinking that through correctly. So when you do a V-carve, it does change a lot of things. The way you have to think about things. Your inlay is not going to, because and you'll see this in a second, if I was to cut out a mirrored image of this without making any alterations, I just went in and cut, like when I did with the laser. When I did this with the laser, I simply just burnt the pocket, burn it really deep, and then took and cut out the exact same piece. I might have added a little bit of kerf when I did the cutout piece, and then I just pressed that into the pocket. It was done. I didn't have to add any additional, 2 or 3 millimeters, because I'm cutting straight up and down with a 90-degree cut with that laser. And I see I got a comment here. Brandon says, try Scorchworks F engrave. It's for engraving and V-carving. It might be easier. I don't know what Scorchworks is. It's free. Don't know anything about what and it's for V-carving. Yeah. And this channel is Hobo with wood chips, but it's going to be talking about CNC work and engrave, but really focusing on Millmage. Millmage, embracing it, learning how to use it, and it's for folks coming from the laser world who have no idea what they're doing, and they're trying to use a new software, Millmage, and Millmage hasn't even got it completely dialed in yet. It's in the pre-release right now. It's not officially released yet, so we're trying to get ahead of the game. So if Scorchworks or any other stuff is just a different type of software, we're just strictly trying to focus on how to use Millmage. And right now, today is a little bit more of about theory and why you have to do what you do when you do what you do for V-carving, be it with Millmage, Vectric, whoever, because this is strictly about why you have to make the modifications that you're making to your pockets and your mail inlays. I've also spent all week this week testing different ideas and theories, and I've created a calculator that calculates the perfect mail inlay and tells you what you need to do, because I'm getting ready to show you the roadblocks and stumbling blocks you run into with creating the male part of this inlay. We just looked at what would be the female part. If Millmage is so different than industry standard software for mills, then should we, after all, this, Jesse, I've been saying this from the very beginning. If you are an experienced CNCer right now, if you are using Vectric or V-carve or Fusion 360 or any of those things, and you have a really good working grasp of that, and you're doing some pretty good CNC work, then know right now, Millmage is probably not something that you would be interested in looking into, because it's in its infancy. They're still working the bugs out. They're still modifying and creating things. There are some things that I like about it, that because I have used easel, I've used a whole bunch of the different softwares. because I do have a much, much larger CNC machine that I actually had to give up on because I could not afford any of the really good software. So what is Millmage? I think Millmage is going to be a really great software for people who are transitioning from the laser world, because that's Millmage is an offshoot of Lightburn. So it's a lot of its interfaces and it looks very similar, but they've implemented a lot of the CNC world, but they did not embrace the vocabulary of the existing CNC world. So it's a little bit of a, and if you don't know anything about the other CNC world, if you're not going out onto the YouTube University trying to learn how to do CNC work, and you're not hearing all of these other terms, then it's a non-issue. But if you have an existing knowledge of the CNC world and other softwares, then Millmage is not yet the software for you to embrace. I believe it will get there, because I can't think of trying to use my laser with any other software. And I can see that, in the future, I can be saying the same thing about Millmage is the absolute only one that I want to use with my CNC. But this channel right now is, and we're embracing two things. Don't know what I'm doing, figuring it out, but not only am I figuring out the CNC world, but I'm also figuring out Millmage and how others that are in the same shoes that I'm in can progress together. So yeah, Jesse, I would not, if you've been using Vectric for the last 3 years, I wouldn't throw it out and go get Millmage, because it's not there yet, but it will be. All right. So I just showed you a 10mm dot doing the V carve and how the V bit changes it from just a circular engraving to a circular engraving with the 30-degree sides, because we're using a 30-degree V bit. Let's go look at what happens with the male insert. So say, okay, get rid of that. And actually what I'm going to do is I'm just going to simply draw a rectangle right here like that. And then I'll select this piece and we'll put it in the top center. And we'll duplicate that, Control D, and then we'll say A, subtract B. Well, subtract A, subtract B. There we go. And say okay. All right, now there's what the pocket actually looks like. All right. So I've got this, large piece of material. And if I look here, that should be 10mm. There's my 10mm disc cut out. And there's my 30-degree side. So if we take this, say, okay, go away. Take this one and move it up out the way. You'll see that fills that bottom void. All right. If that was flipped over horizontal, flip it to where it'd be laying flat in there, it would fill that entire bottom. But I've got this gap that V-bit created. So you have to allow for that whenever you do the male insert. So here's a male insert that I've popped out there. And if I put it, align it to the top, there, everything's filled and that looks good. There's no glue gap. There's nowhere for it to squeeze out. There's going to be all kinds of fitment issues. And John says, Millmage is like a baby learning to walk. It will take some time, but it will get there. Yep. All right. So if we want to leave a, say, 0.2 of a millimeter glue gap, Simple enough. If that female pocket was engraved at 3 millimeters, then whenever we create the male, we only want to leave it 2.8 millimeters proud off the surface. By making that only 2.8 millimeters proud, that leaves that 0.2 of a millimeter gap between what is essentially the top of this when it fits into the bottom of that. That's easy, right? Well, here's what happens. If I just take this right now, that is, in fact, what I'm going to do to keep all my geometry the same, I've got my control arrow set to 1/10 of a millimeter. I'm going to move this up 0.2 of a millimeter. So now I've got 0.2 of a millimeter gap at the bottom, but this is still overall 3 millimeters tall. So I'm going to change that by simply bringing me a toolpath down to here. There we go. And let's go to that. And I need to actually I'll just I'll use the scissors. I'll cut that and come over here and cut that and then cut the top off. There we go. Go back here, get rid of that one, put that on the black layer, and then we'll weld those together. All right, so now that is overall height 2.8 millimeters. So it's the right height, 2.8. And by raising that up 0.2 of a millimeter and keeping this still there at 10 millimeters, I've got a little glue gap here for fitment on the side. And I think in the Millmage software, that's they have an allowance where you can remove material for when you're doing stuff, but their online documentation is it's full of placeholders. It's incomplete. There's no explanations for what this stuff does when it does what it does. So I cannot fully understand what it's doing when it does what it does. So I went out and created my own calculator and to figure out how to create this male insert, because here's the problem you have. When you're using the CNC to engrave, you're not engraving that, you're not creating that path for your male inlay from that top surface of 10 millimeters and coming down. You've got your base that you've got to carve out, leaving the remaining top surface. So on your CNC bed, you're carving it out like this. You can't put in the value of 10 millimeters. You tell it you've got to cut out this distance, which was 13.23 millimeters. Well, short of sitting here and doing something like what I've done right here, how in the world do you know what that is? Well, if I understand the operations in Millmage correctly, it already does some of this. But here's what I did. I have created a calculator that works for me, and I'm going to put it on my website so everybody will have access to it. But if I take this right here, we're going to put it back and we're going to align it to the top of this. And I'm going to put this one on a red toolpath and we're going to put it there at the bottom center. All right. So there you can see that circle, that disc fills that entire area up right there. Well, how do I get that up there? Well, if I go to let's see here. And I'm going to go to the advanced calculator, and I'm going to use a 30 degree angle V-bit. And I'm going to do a pocket depth of my female pocket, existing pocket is 3 millimeters. I'm leaving a 0.2 of a millimeter glue gap. My V-bit has a 0 point. It's a point, comes to a point. And I'm using the side clearance of 1/4 of a millimeter. We'll see what that looks like and calculate it. My calculator tells me I need an optimal toolpath offset of 1.05 millimeters. And my male height should be 2.8 millimeters. But that 1.05 millimeters, let's look at that real quick. So if I select my original piece and come over here and do offset, outward 1.05, don't delete the original and say okay. Now, if I take that piece and bring that right up here to the center of that, well, that one, I'm still working on the mathematics. I thought I had it dialed in, but it's not quite there yet. But you've got to do an offset of your original piece to make up for that V-carve in order for it to be wide enough at the base to fill that entire V-carve area. Let's see, go back. So yeah, we talked about it's John says it's in the baby stages, and I started with CNC using VCarve Pro, then later got a Rolly XW, and then downloaded Millmage. Since that using Lightburn, I think Millmage is easier to understand. I think that Millmage is going to be a whole lot easier, a million times easier for laser users to fully embrace and comprehend when it's fully functional, and they get that. And I guess because they're still in development, I feel like especially as long as they've been working on Millmage, that the documentation should be much further along than it is. But it's as if the documentation is a complete afterthought, and it's totally useless. It really is pretty much useless. But it'll get there. Whether I decide to get into CNC or not, I find the subject very interesting, so I will continue watching and supporting. Thank you. Yeah, don't forget to like, share, and subscribe. You said 2, but you put in 1. Did I put in the wrong thing? 2, but I put in 1. What you talking about, Willow? Oh, no, the pocket. Let me go. I think you didn't take into account the bit width in the calculator. Yeah, the bit width. It's all in the background, Chris. And in fact, I don't even know if this calculator, up until 10 minutes before going live, I did not have a functioning HTML calculator that worked on the website. I only had my desktop version. So just for giggles, I'm going to go open my desktop version, minimize that, close that, and that. I need to get where I can see it. I'm curious if my desktop has a different result, because I've been tweaking this all week long, and I have used it. It worked, but it was working on my desktop version. So let me just move this over here. I don't want to lose that. And is this properties? Yep, that's the right one. All right, open that. Open Sesame. All right, we're going to switch places with that and that. And I'm curious. We do 30 degrees, pocket depth of 3 mil, 0 tip point. Calculate. No, they came up with the same. Anyway, But there's where the whole problem comes into play is your inlay, your male inlay is not the same size of your female pocket. It has to be a larger offset that you cut out with, and this is talking about V carving, strictly talking about V carving. And in talking with Chris yesterday, if we go into Millmage and we look at the operation codes, if I select this 10 millimeter dot and I go in here and I say a new operation, I have the female inlay pocket, and I don't know, and I would love to hear from you guys who are using Vectric and other things. Does their software have similar operation setups like this, to where you just kind of have to you tell it you're doing a female inlay, and it takes that into consideration? But here I'm doing a female inlay, and then I'm setting up this entire operation. So I'm doing the 30 degree bit, and I'm going to do a final depth of 3 millimeters, and I can do 3 millimeters per pass. That's good. But if we look down here at and let me apologize to Chris right now if he is the person who come up with these illustrations. But I have always had a hard time understanding what, and this goes to, I swear to you, I believe it's right brain, left brain way of, recognizing things. I have never understood the graphics created with Lightburn and now or with Millmage. The visual representations of what the tools are supposed to be doing, I have never comprehended what any of those visual representations look like for some of the complex tools, like the distribute tools and all that stuff. It took me years to figure that representation out. And this is no different. John says Vectric does the calculation for you and also adds an extra vector outline for you in the male inlay. Okay. Well, here in Millmage, this is the female inlay, and I've got a visual representation down here that shows the dotted line as being my actual path. And you can see that the bit is going to be inside the line. It's not cutting the line. It stays inside the line. And if that's the case, and it knows that I'm using the 30 degree V bit, then Chris, is this supposed to, since it's staying inside the line, is that point and that going to be moved inside so that the top surface is still only going to be a 10 millimeter dot? Or is that 10 millimeter dot going to be wider because of the V bit using Millmage's operations? I haven't tested that yet. But the female shows the bit staying inside the line. And then you have an allowance right here. And if you go and look at how they define allowance in the operation, or in their online manuals, it's not an accurate definition. And when I contacted them, they just said, yeah, that's not right. It's just a placeholder. So, and if they don't even have the tooltips that pop up here. So usually you got your tooltips explaining what that is, but it doesn't have it there. But here it shows you staying inside the line, and we'll say, okay. And then I'll apply that to that operation. And then if I go in and go to new operation, and I'm going to create the male inlay, now you look and see you've got that ... That's your star to begin with that they had here as a star, but it's going to go outside the line. It never comes inside the line. So that's should allow for your two pieces to mate up together, because one's carved outside the shape, one's carving inside the shape, and then your allowance should be, let's see, let's go ahead and finish this up here. Our start depth will be 0, but which one are we going to do? 2.8. That allows for the glue gap. And there we go, and say okay. And then assign that to the male. Now, you're not going to output those both at the same time. Obviously, you'd output one and then the other. And Chris says, no, tooltips is a good indicator that it is a placeholder. No tooltips is, yeah, no tooltips. All right. So, and another problem that I ran into, because when you're doing V-carve, and this one was a good example of it. Look, I want you to look at how wide, because this was a 3 millimeter groove. It's a 3 millimeter groove for that star, and that's a very good, it's cedar, so it's rough. Cedar does not carve well. Cedar engraves really well. I make some really nice engraved cedar plaques with the laser, but I don't like how it does with the CNC. But it's good for practicing. But it's chopped up and a little bit rough because of the tear out, because cedar's so soft. It's almost like trying to CNC in styrofoam, almost. But that's a wide path. This is the male insert, and look how narrow it is. And that's because of the V-bit. And if you look, if I focus on it there, you can see there's a whole lot of tear out at the top edges, because it got so narrow, and because the bit, the V-bit and the material, but those areas where you're just chunking out a whole lot of the material, that's obviously not going to work. Where is it there? Yeah, that's not going to work for an inlay. And you can prevent that by, one, not using cedar, and then two, keep that in mind when you're doing V carving, because what happens is this. If we go over here and look at this representation I've got, here is a 3 millimeter. No, that one is a 3 millimeter by 2/8 of a millimeter square, or a rectangle, I should say. And move this over here so you can see it better. There we go. So that's 2.8 millimeters tall. And it was 3 millimeters wide at the base. Come on, grab that. There we go. And put you in the middle. There. Get you in the corner. There you go. And get you in the corner. I'm using a 30-degree V-bit. And what happens is the V's come into contact with each other before it gets to that 2.8 overall height, end up making it even shorter than it should be. So you almost need to know what the limitations are on your bits, and that's just stuff that comes with experience and use. It's like, okay, well, I don't need to do anything that narrow with a V-carve. You can do it all day long with your laser, but when you're doing the V-carve part, that V-bit is going to be reducing that top piece of that male inlay if you're doing if I wasn't doing if I did a solid star, if I didn't try to do the outline, then it would have been an issue. But when I come in here with a 3 millimeter offset of the outline star, now it starts to be an interference problem with the actual V-bit. So there's a whole lot to learn in this world, about the CNC world. I got my mind wrapped around the laser part of it pretty good now, and I'll get there with the CNC. And I do not want to discourage any newbie, anybody who is just now beginning to learn CNC, or they're wanting to transition out of lasers, especially if you're transitioning away from, not away, but to include and encompass CNC work with your laser work, and you've been using Lightburn, then by all means, you need to get Millmage. You need to get Millmage, and you need to get it now and start going on this journey with me, and we'll figure this thing out. Because I have used easel, and it is, and if there's anybody watching that used or uses, or it don't even exist anymore, the very first X-Tool software that they had out, I don't even remember what they called it. It was so pathetic, so elementary. It limited you on what you could do. Well, XCS, which they have now, is not what I'm talking about. This was prior to XCS. Well, easel is as bad or worse than what that was. It really handcuffs you and ties your hands on creativity and capabilities. Millmage gives you that freedom to create and do things that you're familiar with Lightburn. So I strongly encourage you, if you're just beginning to, if you're thinking about it, yes, go grab and grab Millmage, and let's go on this journey together. But I am eagerly awaiting the official release of Millmage with all of its documentation to fully understand what these things are doing, because no, Chris, that's not that's additional. That's additional on a 3mm piece. Go back over here. Let's see, switch and switch. Yeah, the Millmage is CAD and CAM all in one, and a couple of guys I've seen one or two of them I used had CAD and CAM all in one. But it's expensive. So Lightburn's really reasonable. Not Lightburn. Millmage is very reasonable compared to the others that are out there with similar capabilities. But if I make this, let's put this one back to 3mm and 3mm, because this is supposed to be representing the female pocket. We'll say this is originally 3x3. All right. And that's what this one over here is this one will be 2.8. That's with the glue pocket. Oh, come on now. I did the wrong one. 3 and 2.8. And put it in the center of this one. Not center, put it at the bottom. There we go. And why didn't that go? I wanted that width. That's supposed to be 3x3. I had it locked. There we go. And I did that in the wrong order there. 3 and 2.8 there. Did I do it? No. Why am I having such a hard time today? I did it wrong again. 2.8 and 3. Oh, if I got the aspect, I keep locking. How did I keep locking that? The width is 3. The height is 2.8. And that one should be 3. There. And my anchor point is what's messing me up. There we go. All right. So my original pocket is 3mm deep. And this was what I wanted it to be, 2.8 for my male. So there's 0.2 of a millimeter glue gap right there. But with these points coming to here at a full 3mm here and here at 30 degrees, only 3 millimeters wide, you lose another 0.2 of a millimeter in height of material because the V bits intersect with each other before you get there. So the fix for that would be don't do anything that narrow, 30 degrees with or 3 millimeters with 30-degree V bit. The answer would be to use a 20 degree V bit or a wider path. Ordinary says, I really like Carveco, but it does not have a post processor. It has only the CAD side. You have to save the G code and select. Yeah. The abilities it's built into to Lightburn. In fact, come back over here and we look at that and we go to the female inlay and preview it. And it's extremely good and a very, very high resolution. They've got this dialed in a lot. Very nice. The abilities, you've got to move it around and scroll it around, and you can see your toolpaths here. And let's see here. Go back to the operation. Step over. Let's reduce this step or increase. Well, actually at 50%, that's as high as we can go. Let's do this then. Let's make this a little bit bigger for a second and then go to preview. I was looking to see, and I'm curious. Actually, that was going to show me. Yeah. I've got a family member that's called me twice now during this stream. Let me just send them a message that I'm on live stream. All right. The default gap looks to be 4.4. I hadn't looked at that part before. I use Aspire for design. I also use Calculate for G code. You set the depth, the bit goes down. So why would it not? Or you set the depth. You set the depth bit goes down. So why would it not go down 3 millimeters? The female pocket is going down 3 millimeters. Turn Sam off here. If I go over here and look at the female inlay, the final depth is 3. It's going down 3. So if you're talking about over here, there's this one. That female is going down 3. All right. And the female pocket, and this is where it gets really when you think about the female pocket versus the male pocket, you have to think of the inverse. The male pocket is the inverse of the female. In fact, if you're not doing a symmetrical inlay, then you have to flip that to create the inverse of that so that when it carves it out, it's going to be oriented correctly when you sandwich them together. So go back over here to these two. Actually do that. Do this. And I'm going to rotate. So you're seeing that this is actually the male inlay. I'm going to flip it around because it's going to carve like that. And this is going to carve like that. So this is from the bottom of this to the very top is 3 millimeters. The female is going to engrave 3 millimeters deep, but you want your male to only be 2.8. so that you leave that 0.2 of a millimeter glue gap in there. And that's what this is representing here. Here is 2.8 millimeters tall, so that would be the male part. And at 2.8, you've got if your piece is this narrow, those V's are going to overlap one another, effectively reducing the overall carve height. If you put male and female on different layers and colors, it'll be easier to follow. And what would be super cool is if there was a way to have the visual, which would just be for visual representation, as if those were you could show them in a field solid, so you could see that this is all field and that's a solid, that's pocket. I don't know. But if that was on different, and then plus, I don't know how well it shows up on the screen in these other colors. And if I come over here, this one is the male and that one is the female. But the problem is if, let's see if I can, it's hard. And there I'm trying to show you a cross section of that, a cross section of that star. And from the base, the very base of that star, where it meets the material, that's 3 millimeters wide. Or it's actually more than that because I did the offset. It's, whatever it would have, because that one I calculated and it worked. So the very base of that star is over 3 millimeters wide. But when it comes up to that top, they begin to cross each other out. I'll have to check it, but I think you're creating a glue gap plus Millmage is creating a glue gap as well. Yeah, I don't know. And that's what I'm saying. A lot of this is I'm getting in here kicking tires, and that's the other reason why I'm using cheap material, because I'm doing this was the good one. I got a bunch of stuff over here that's just trash that just and the setup time for CNC work is a whole lot more extensive than it is with your laser. It's a whole lot more work to test, a whole lot more work. And that's also the reason that I put my big CNC in mothballs, because it's 4 times as much work to set up on a machine that's 4 times larger versus doing it with the little Cubico. But you have to think about this as the inverse of this. The bottom of this, where your male inlay meets your waste material, is actually the top of your inlay. It'll be what's going to be exposed once you put them together, glue them, and finish it. So it's a journey. It's a big journey. And I thought for sure I was going to have my calculator completely finished, because here's my mindset with the calculator. Once Millmage has got all of the kinks worked out of it and they've got all of the documentation set up there, you know what? I don't need Millmage to do those calculations for me. I understand what calculations need to be made. I know if I've got this 10 millimeter base and I'm doing a 30-degree V-bit, and this is what's absolutely frustrating. And I've told you this a couple of times. I wish I had paid more attention in my geometry classes. I hated geometry in class or in high school. At that time, I could care less about learning about angles. The only thing I had in my mind or on my mind were curves, specifically Kellyanne. I didn't care anything else about anything else. So trying to grasp those angles and the theories, and I totally lost on me. But when I created this calculator, and this calculator that I've got, this one needs to be dialed in. It's still, you can see this is Hobo's V-bit inlay calculator. I had to do not geometry, but I had to use a whole lot of trigonometry to help try and figure it. Ain't that smart? And you can see here, this is version 2.10.5, which means the first version I had was just a basic calculator. You put in your angle and your pocket depth, and that was it. And it calculated everything else. But I said, you know what? Somebody might want to do more, have more control. They want to control their pocket depth or their glue depth, and they want to control their side clearance. So I added more features to it. And then once I added that, created that second version, there's been 10 versions of this second version. And now I've modified that one 5 times, and it still ain't got where I want it to be. And I thought I had it dialed in perfect, but I fought it down to the last 15 minutes before going live. But it will be. And now, and once I get that functioning right, and I've got all of and this very math that I was talking about that I had to be figuring out may be going on behind the scenes within Millmage. But I don't understand how they use it, where they use it, and how much of it is like where it talks about the allowance. I've got side clearance. I've got side clearance of 1/4 millimeter figured in. And if we go to Millmage and we go to the female operation, they've got allowance 1/4 millimeter. Is that allowance the same thing as what I'm saying is my side clearance, Chris? Various glue gaps is good for different glues for different materials. Yep. And being able to control that and change it. And that's the reason I implemented that. But in Millmage, where it says allowance, 1/4 millimeter, is that effectively the same thing that I set up for my side clearance? The angle of the dangle is the direct correlation of the swerve of the curve. Sir, yes, sir. And Chris says, yes, that's the way I understand it. All right, well, here's my problem, Chris. I don't understand why they have allowance built into both the female inlay and the male inlay. Why bother putting an allowance on both pieces? Is anybody got with more? And it doesn't take a whole lot of experience to be someone who meets this criteria. Does anyone who has more experience with doing V-carve inlays have a reason why you would want to do an allowance on both the male and the female? Yeah, it'd be a good thing to watch because, you know, here I haven't gone over. There's only been about 8 or 9 videos. I'm still learning. I'm still figuring this out and testing and helping explain how the operation's set up. The videos are good to watch, but you haven't missed a whole lot. We're just getting started on this journey. But I don't understand. Here is the female inlay, and I have the ability to put in an allowance of 1/4 millimeter or whatever I want it to be. 1/4, I think, happens to be their default. But if we go to the male, then you've got another allowance here. And is there a reason why you would want to do, if you wanted a total of 1/2 millimeter allowance, do you need to do 1/4 on one and 1/4 on the other? Or if you only want 1/4 total, then is that not equipped to say, okay, just leave it, do 1/4 allowance on one? And I also recognize that just like when you're cutting material with your laser, different materials are going to react a little bit differently, but I don't expect you to have as much of a variation. If anything, like working with this really, really porous, soft cedar, it's going to have a whole lot more tear out and blowout than a harder maple or walnut or a really, really true hardwood. So those are going to be more realistic to the actual, parameters that you've got set up in there. Whereas this, it's just chipping away. So it's going to be bigger than what you put in there. And that's, well, Robert, I don't think Robert says, can you put, you can do a positive one in it, but then that's just going to zero them out. And that'd be just like doing zero allowance. And you do need an allowance. You need a side allowance. You need some side clearance. What happens if you take it out of the female setup? Well, that's the question. You can set that value to whatever you want it to be. You can tell it to be 0 and go on. But my question, coming from a place of ignorance, and I don't use that term. And so many people get so offended by words. So many people get hurt more by words than they do if I was to go up and smack them in the face. Ignorance is not a negative thing. I am ignorant when it comes to CNCs and Millmage. I've got a lot to learn. And to say that I'm ignorant in Millmage and CNCs is not an insult. It's a fact. So I'm coming from a place of ignorance with why they would have the ability to put allowance on both. Because if you're creating if you were just creating a regular pocket, they've got an operation called pocket. But here, this one is specifically the Inlay female pocket that has this ability on it. And then they put that same ability on the male. Why? Is there a reason for that? And Chris says, it could be just so you have the option of using on either one or the other. But why? And is that the case? For me personally, with the way I've wrapped my head around my calculator, is I'm not adding anything to the female. Female just gets done. Then now I need to create a male inlay to fit into my female pocket. So here are my fixed parameters of my female piece. What adjustments do I need to make to the male to make it fit in the female? And that's the way my calculator is working. If you're using the term of ignorance as unknowing, well, that's what ignorant is. You don't know. Even for people that's trying to use it as to be mean. Good God, you're ignorant. Yeah, well, they're ignorant of what? They are unknowing. They're unknowing of a lot of things. And it is about the intent behind the word more than it is the word. And that goes with any word. If society decided next week that for some reason the word green is now the green, not the color, but we're going to use it as while he's really green in his job. He's new. He doesn't know what he's doing. Now, if I just turn around and say, "Oh man, you're green," I'm like, quit being green. And the hate behind the word, and then that's more than anything. And people get put on your big boy britches, and just don't get your feelings hurt. Does it say that the inlay is for V-bit or just for an end mill? Well, it depends on how you set this operation up. If we come back over here, right now I'm selecting my tool and telling it I'm using a V-bit. But if I come back over here and tell it I'm doing an end mill and I'm just doing a 1/8 down cut and say okay, then I'm no longer using the V-bit. It's going to set up and do it for my end mill, but it's still got the ability to do allowance. And that one is a little, doing an inlay with the laser is pretty much giving me the same results as doing an inlay with a regular end mill, because it's got a 90-degree wall on both. It's 90 degrees on the pocket and 90 degrees on the inlay. And when you look really, really close, you can see that gap. You can see it no matter what you do, you're going to see that gap. And I think that's the reason for the V carve, is the V carve having that flared edge. It fits down in there better. You get a much, much, much tighter fit. And when you've really got it dialed in, if you look at some of the inlays that Garrett does on the IDC Woodcraft, you cannot see a line. It looks like it's the same piece of material that has just been stained. And the V carve just gives you a much, much finer result when it's done. For small inlays, I would say you want female, maybe bigger, but other times you want to do, you know what? And there you go. Hey, bam. Jared just knocked it out of the ballpark. Chris, Jared gets the cardboard cookie in this stream, because what he just said makes more sense about why you wouldn't want to have the ability to do your allowance on either or. If you're doing that really, really fine, small pieces, then if you don't do any allowance on the male, but do all the allowance on the female, then that's going to negate everything that I was just showing on that, where those V's come into play. Maybe not negate it, but take out a lot of it. I think that might be a reason. And see, I see that's why I said there's got to be a reason they've got it in both. And because I have no idea, because I don't know what I'm doing, but that makes sense. That would be something worth trying and experimenting with. Let's see. Where'd that go? The end mill. That might be because I had it. Let's see. Let's go back over here. I'm going to switch this and say, okay. Yeah, I think that's because I had already changed it. So let's go over here and say a new operation. I'm going to do a female inlay, and I'm going to select my tool as a down cut and say, okay. So female inlay. Yeah, see, there it is. It's because I had already changed that value. So when I changed that value and then went back and changed the bit, it didn't put it in. But there, I've got a down cut end mill, and it's got the allowance on there. That's their default for that field, is a 1/4 millimeter allowance. I don't know that, for people who don't know what they're doing, I don't know that it's a good thing to have a 1/4 millimeter allowance as a default on both male and female, because I don't know that you need to do. In fact, I know you don't. I can't think of any reason why you'd want to have a 1/2 millimeter allowance combined. And Bob says, I'm not ignorant. I'm just knowingly challenged. You can give a 0.01 to the female and 0.1. Yeah. You could split it. But there may be, as you pointed out, though, there may be times when you're doing really, really small pieces, by not doing any on that male piece and do it all on the female. I think that would work. Check out. Is that spelled correctly? Bro Winwood? Is that spelled right? I watch a lot of Garrett. I don't know that one. I'll check that out, look it up. But the biggest thing that for folks who are not familiar with doing those inlays, if with the V carve, the very center, the very bottom of that, the lowest point of that star is 3 millimeters wide. But at the top surface where that star opens up, it's quite a bit bigger than 3 millimeters.
Where's your glue?
Glue? I don't have any regular. Well, actually, I do. 1 minute, folks. Right there. CA glue.
Oh.
That's a super glue. And it might be stopped up, but here you go. Sorry. Bro in wood. Okay. All right. Don't know what. I'll be curious what that, how he came up with that name, what it means. But anyway, so this was 3 millimeters at its lowest point. It's much wider than 3 millimeters. We're at the top edges of that. So this was supposed to be 3 millimeters at its topmost point, but because the V's overlapped, it chipped away that. It got much lower than 3 millimeters, increasing the amount of blowout. And it once before I broke it in half and I put that all in there, it was a sloppy fit. It was a very sloppy fit. But I was trying, and this was done using the presets in Millmage. I used their presets and it was just very, very sloppy. So then what I wanted to do, and I've been, because I don't have any idea how to code. I have never written it. Well, I've written DOS. I used to do quite a bit in DOS programming back in the late 80s, but I've not worked with anything in the way of Python or I haven't done anything in HTML in 30 years. So I'm behind in coding, but I created that calculator myself and I'm really, really happy with the way that it's coming along. Because this is going to work if I was to not use any of the features in Millmage. If I just drew out a circle and put it on a regular pocket for whatever the engrave is going to be, and then use that same path parameters to plug into my inlay calculator, I've got a new path for the male inlay, and I didn't have to rely on any. I controlled everything. I don't have to assume whoever programmed the parts going on behind the Millmage, or because right now I don't understand what's going on in Millmage, but I've got full control over this. Where did it go? Wrong one. There we go. I got full control over all the parameters in this calculator, and it's going to calculate and tell me, hey, do this offset. I've got to get my math dialed in, and I did. I did have it, but like I said, all the versions I've been doing, I would get it working and it worked great. And then I need to change something, tweak this, tweak that. And all of a sudden now the math don't work. And that's where I'm at right now. So I always do Millmage first, or I always do the male first, then slowly increase the female to get it to, oh, well, and that works for you. And that's actually, well, yeah. Because then that's actually a pretty good tip there, Mr. Chris. So if you do the male first, you got the male, you're holding that in your hands. As long as you engrave your female, it's on the machine, glued and secured, or clamped and secured. You don't have to, and if you don't have to move anything besides clear the CNC, then take your male and test fit it. And if it's not, yeah, that's actually pretty good. That's why I like this. I get tips. I'm learning tips on chips. I found it is just start with a small circle and then start playing with your offsets. And once you get it dialed in, it should be for any of the designs. Yeah. and that makes sense too. And what I was trying to do is I try to learn as much as I possibly can when I do a test. Uh, so I was trying multiple ideas when I was doing this. If you look, the wood grain there is running north to south. And when I did this pocket, I engraved it like that, and with the wood grains doing east to west, so that whenever those, because these are two similar identical pieces of wood, if they would have gone together and done what I wanted them to do, once I put them in there and glued them up, then I was going to have the grains contrasting each other to make that star jump off of there. And so I was playing with different things, different techniques, and wasn't focusing solely on that offset part or the allowance that they've got in there. But I learned that 1/4 millimeter of allowance on both operations is too much. And I need to pay attention to the thickness of that inlay, because the V-carve bit can begin to overlap itself, removing more material than you want it to. So, does that get a cardboard cookie? That's a really good idea. But I think the gold star, that yes, you get a cardboard cookie, but the gold star and the cardboard cookie goes to Jer for the idea of reducing or doing the allowance on the female instead on the male when you're trying to do small pieces like this. So, all right. Well, boys and girls, I appreciate you coming and hanging out for a little bit. I wish that I had more, but like I said, a lot of these and these early going ons is about figuring out the software, the math, and before you can start creating physical pieces, you got to have a full understanding how this stuff is doing what it's doing. Have to make sure you surface both pieces to make sure not to start with warp. Yeah, and right now, because of what I'm not anticipating anything that's going to be a premium piece. I'm still learning technique. I ain't worried about, these have been through a planer, surface planer, so they're good and flat. And this stuff, this is untreated cedar pickets that I bought, fence pickets that I bought from Home Depot. And I'm not going to break this one, but if you watch, I'm not going to try and break it intentionally, but there's enough flex in this piece. Yeah, I'll break it if I flex it too much. So before you start to see the flex, it'll snap. But this flex is extremely easy. You've seen how easy I snapped that. So even surfacing this, I don't know that you need benefit from it. But for my walnuts and my maples and stuff, when I start actually trying to get quality stuff, yeah, absolutely. I'll make sure that they are surfaced properly. All right. Well, we're going to get out of here and go see if he's got his shoe glued up. I think we both need to buy some new shoes. And then go get some dinner, and then back to lasers tonight at 9. And who knows, Patrick might even drop in and say hello. So 9 o'clock Eastern time, we'll be back for lasers, Hobo with Wood lasers. Y'all have a good evening. Hope you found this somewhat informative. Like I said, I'm learning. We're learning together. Thanks for your contributions to today's stream, and we'll see you this evening.